Welcome. This is part one of vectors. We're going to learn today what a vector is and how to represent a vector graphically. Okay, so a vector is defined as a quantity that has magnitude and direction. As opposed, the opposite of that would be a scalar. A scalar only has magnitude. And when I talk about magnitude, we're talking about size. We'll see that in an example. So an example of a vector would be like velocity. So the size of the velocity would be something like 60 kilometers per hour. The direction, of course, would be according to the compass or so. We'll look at that in a second. Forces are also vector quantity as well as displacement. Some examples of scalars would be like time, temperature, speed. There is no direction to time or temperature or speed, so there's only a magnitude or a size. Notice in the drawing picture on the right, you'll see that the car is moving around the corner, and so you can see the vector changing direction, going from a south-southwest sort of direction and then pointing back towards a sort of a southeast. And then you'll also notice that the length of the vector gets smaller as it goes around the corner, which indicating that it's going slower at this point and then picks up speed. So we're going to represent vectors with arrows. So a vector is a graphical representation of a measurement that has magnitude and size. We're going to represent it with an arrow-tipped line segment. So it's very important to understand that line segment has a very specific length that represents the magnitude, and of course the arrow represents the direction. So we're going to draw it to a very specific scale. Examples of vector quantities, again, would be like displacement. So to show this on paper, we would draw an arrow, label it with a D for displacement. Velocity, this way. Forces can go left or right, or up or down. Okay, so we have to take a moment and talk about directions. Directions are sometimes represented by the compass, which I'm showing in the lower right here. North being 0 degrees, that would point towards the North Pole, according to a compass. And then going clockwise, we go 90 degrees would be east, 180 degrees south, and 270 degrees west. Back to 360 and 0 are pointing in exactly the same direction. So, for example, by a compass, we might represent a vector as 15 degrees, which would point off to about this direction, 172 degrees, which would be down in here, and then 327 would be all the way around up into this direction. We're going to reference the cardinal directions, the north, east, south, and west. So we're going to see some vectors that have those directions as our reference. So for example, 75 degrees would be a vector that goes off like that direction on the compass. We'd also represent that as 15 degrees north of the east. So the east is our reference, and we're going towards the north, a total of 15 degrees, which puts us at the same place as 75 degrees. 15 degrees south of west would be one that goes off in that direction approximately, and it would be the same thing as 255 degrees if we went all the way clockwise from 0. And then 15 degrees west of south, so south is our reference, we go towards the west line, 15 degrees, which also puts us at 195 degrees. Due east, due south are also ways that we might get our directions, as well as due northwest. But remember, if it's due northwest, that's exactly a 45-degree angle between north and west. Has to be exactly, not approximate. Okay, so now we're going to look at how we draw vectors to scales. And so I have some steps that we're going to go. Okay, so we're going to look at the steps that involve in how to draw a vector to scale. So the first thing you do is you have to choose a scale. You have to choose one that will fit on your page. Could be something like 1 centimeter equals 1 meters per second if you're doing, maybe a small number of meters per second, or 1 centimeter equals 5 kilometers per hour, or something like that. Then you calculate the length of the line segment using that scale. So we're going to use this as a scale factor for drawing our line segment. So it could be something like 1 centimeter equals 1,000 kilometers per hour. And so therefore we would have to scale that down so it fits on our page. Step 3, we then draw the reference line. It's usually north, east, south, or west, or sometimes it could be the ground if we're doing a vector that is up from a certain number of degrees up from the ground, things like that. We then measure the angle. If you need, there's a link under this that will show you the real review on how you use a protractor. I'll show you how you do that on examples coming up. We then measure the line segment with the ruler. So we've already measured the length. We measured the angle. Now we measure the line segment. And then we draw the vector with an arrow ending on the line segment. I'll show you some examples of how to and how not to do it coming up. And then we label the vector with the magnitude and the direction. Make sure you're using the magnitude of the given vector, not the number of centimeters it is that on your scale drawing. Be sure to draw vectors large enough that it's useful. So you don't want them really small, and of course you don't want them too big that it doesn't fit on your page. Okay, so we're going to do this as an example. So we'll reference back to the list of steps. So the first thing we're going to do, we're looking at this 150 meters per second at 60 degrees. So the first thing we do is we're going to choose a scale. So we want it to be large enough but not small enough. I went ahead and chose 1 centimeter equals 10 meters per second. That's a reasonable amount. You want to try to keep the scale as usable numbers like 10 or 5 or 25 or 100, things that seem reasonable. The next step is to calculate the length. So ours is 100, we want 150, so we take the 150 meters per second and we divide that by 10. So our vector is going to be 15 centimeters long. Okay, step 3, we're going to draw our reference line. So our reference on this, because it just says 60 degrees, we're assuming that means by the compass. So our reference is going to be the north line. So we draw a dashed line that indicates the reference, and we label that north. So the reader knows exactly what the reference is. So we draw that with a straight edge. We then measure the angle. So we take out our protractor and I'm going to put the end, this hole right there, I'm going to line it up with the bottom of my reference. And it's not really easy, you can't really see it well on this, but you know how to use a compass. I then make a small tick mark on the 60, so I'm going to, whoops, let's try that again. I need a little tick mark, and I'm just going to put a tick mark there, which will be my 60-degree angle. Okay, so that I've measured the angle. The next thing I'm going to measure the vector with the ruler. So I take my ruler out and make sure it's on the centimeter side, And so I am going to line up the bottom of my reference line along the line. So you can see this goes right along the angle that I just measured. And then I'm going to put a tick mark on how far that goes out. All right. So let's see if I can do that. Goes out about right there. And then I measured that. I then draw my vector. And so I have that pre-drawn. And so it goes out that way, noticing that it is 15 centimeters long. It goes along this 60-degree angle that I measured. And so that is my vector. My last step is to label it. So I bring in my labels. I'm going to put the angle inside of the angle, so the reader can see that. I'm going to put the measurement that I'm measuring right along the vector, someplace like that. So there it is. So that is drawn to scale. Make sure that you show the scale. You can show the calculation if it's complicated. This one was pretty simple, but it's easy to show. And then, of course, I'm labeling it with the given 150 meters per second and the 60 degrees. Not too bad, right? We'll do another example. We might get a vector like this one, 730 kilometers at 35 degrees south of west. So going through those steps again, I choose a scale. This time I'm going to choose 1 centimeter equals 100 kilometers, because I couldn't possibly do 10, because that'd be 73 centimeters, which is, 3/4 of a meter stick, and I can't fit that on my page. I also don't want to say 1 centimeter equals 73 kilometers, though the math would be easy. 73 would not be easy for somebody to measure out. I then do the calculation. So I calculate the length of my vector will be, and that simply will be 730 divided by 100, which is 7.3 centimeters. Okay, the next step would be to draw the reference line. My reference line in this case is the west. The west is the reference line because we're going to move 35 degrees south of the west line. So I need a reference line of west. So let's see, I'll just put it right there in the middle of the page. Starting from this end, going towards the west. That's my reference line. I'm going to measure the angle. So I bring in my protractor, line it up properly, put a little tick mark on 35 degrees. I'm now going on the inside scale, 10, 20, 35. It's about right there. Okay, move that out. I'm going to take my ruler, and I'm going to measure 7.3 centimeters out from where I started that. It's not really easy to do with this. I'm then going to draw my vector from the beginning of that to the end. So there's my vector. My ruler out of there. And then I simply put the labels in there, 35 degrees. I'm going to go south of the west to be sure it's inside the angle. And then I put my 730 kilometer label on that. This is a little large, but you get the idea, right? Okay, so there you go. That's how you draw a vector to scale. For your assignment, you see that on the handout that you got, is to complete part 1 of the assignment, and I'll take a look at that in class tomorrow to see how well you did. Okay, thanks for watching.